everybody, welcome back to the channel. So yeah, this is a short educational video really, talking about fuses and the different types that we might find on a narrowboat, the ones that I use, may have kicking about and things. So we talk about those fuses, what they're called, what types they are, what I use them for, and maybe the current ratings of those particular fuses and fuse holders as well. So let's get straight to it. Who's it designed for? Yeah, narrowboat owners, I'd imagine, so they can identify the different types of fuses, and also I'll put a link below where I get my fuses from, so it might help some of you guys out knowing where I buy some of my stuff from. So I'll put a link below to AES, not sponsored by them in any way, automotive electrical suppliers. I get quite a bit of my gear from there, not all of it, but quite a bit. Fuses, fuse bases and things like that, so I get quite a lot of my stuff from there. It's good, reliable stuff, so there you go. Right, let's get into it, and let's start looking at some of the fuses at the low end, the low current end, and the bases, what I use them for, and we work up to some of the bigger stuff. Okay, right, let's get cracking. So there's quite a selection here of all different type of fuses, but let's sort of start at the, well, let's say the most common, the common ones for now, which are where are they? These little blade type fuses here. So let me move some of this away, and we'll just concentrate on these blade fuses and the type of base that we actually put them in. Okay, so these are blade fuses, okay, referred to often as standard blade fuse. They come in all different sizes, so you can see this one is 10 amp, 4 amp, what's this one, and that's a 20, that's a 20 amp there. Okay, so they're all the same size blades, and they all fit in the standard blade fuse holders. Okay, so they just, they are tight, some of them, they just plug into these, and these you crimp into your circuit that you're trying to protect. So I'll pop the drawing up to here if you want to pause and look at the sizes of those blade fuses, but roughly these are around about 5mm in width, and you can buy these blade fuses up to 40 amps. Now, just because you can buy these up to 40 amps doesn't mean you should possibly be using them. I tend to use things like this for maybe bilge pumps, very light loads, maybe a water pump, maybe very light loads. I've replaced a lot of these where they're using a 30 amp fuse. I've seen some people install solar on these, and I don't. So I wouldn't personally install or recommend using this type of fuse all the way up to 40 amps. I would jump onto a different type of fuse. I'm sort of okay 20 amps ish, and that would be enough. I'd go to a different fuse altogether, which I'll show you in a second. So these are standard blade fuses. There are also two other types to go with the blade fuse, and that is a mini blade fuse. I'll put you the dimensions there. A mini blade fuse is a bit smaller and has a smaller, if I just open that a bit, you can see there's two bases together. The top one is the mini, let's move that, and the bottom one is the standard. So you can see that they are quite a bit smaller. Come in all different sizes as well. I don't really use these very often. In fact, I don't even keep any of these in stock. I just happen to have some of these in the van. So I always use the standard ones, okay? And they're all color coded for different, they're either color coded and or they've got the value written on as well. standard blade fuse. There is also a bigger one, and they're called a maxi blade fuse. So there's the standard, there's the maxi. Okay, so quite a bit bigger, and you can see the terminals are also much bigger. Now these will carry higher currents for sure, and the fuse tends to look something like that. So in comparison to a standard blade fuse, they are quite different. These are often used on charging circuits for bell thrusters all the time, and you can see they plug in the same way. Now these are rated to a higher current, and in fact the maximum current in one of the, you can see this one's a 70. The maximum current in these maxi blade fuses is 100 amps. I wouldn't use these for 100 amp because you've got things with the connections. You can't just, so this looks like it's a 6mm cable. I wouldn't be using yellow crimps, inline crimps, to connect that into a circuit and pull 100 amps through it. So I would again move to a different type. Okay, this type of fuse, I have them in the van. I think I ordered these by accident actually. Never use them, but you do see the bases with these maxi blade fuses on things like bell thruster charging circuits, like I said. Right, so that is the three different types of blade fuse and an example of their holders. There are also different types of holders for these as well. I just don't have any. Blade fuses, use them all the time, but I try to keep them on low currents unless it's a different kind of base, a plug-in base for these bigger ones for like I say, bell thruster charging. Now I said okay, 20 amps for those standard blade fuses, something around there, not big stuff. The next step that I use when I'm going up to some bigger currents is let's just open them in the packet, is these MIDI fuses. Okay, so they also well, they need a base. So a MIDI fuse base carrier, this is a single one. They do have a cover on them so you can click that shut, and these are better for some of the next current range up. So there's the base. These are again color coded. That's a 30 amp if you can see that, and there a 40 amp as well. Yep, there's a 30 and a 40. These go all the way up to 150 amps. Again, I possibly wouldn't install these up to that kind of current. I would then go to sort of the next step. So what sort of range am I installing these for? Well, they start at 30. So that next step from those blade fuses, they start at 30 amps. I would install these on solar charging circuits. So I would install these on circuits that are approaching 100 amps, but once I got to 100 amps, I would go to the next stage. So yeah, 70, 80 amps, okay. But anything higher, then I would jump up to the mega fuses, which we're going to look at in a second. So like I say, these are called MIDI fuses, and a MIDI fuse base. They have M5 terminals. Okay, so you can put ring type crimp terminals on there, and they'll take obviously bigger cables for that increased load. So MIDI fuse base, MIDI fuses, great up to 100 amps. Okay, so the next step after that, we would move over to mega fuses. Okay, so these are bigger than MIDI fuses, and this is where the current starts to climb quite considerably. I would tend to install mega fuses on things like inverters, inverter chargers, big chargers, that kind of thing, where the bigger currents are. In fact, these, you can see that one's 250 amps, and I've got one here that is rated at 400 amps, if you can see that. These also need a base, and strangely it's called a mega fuse base. Okay, so now we've got bigger M8 terminals, so beefier to carry that more current, bigger cables, bigger lugs that are required. These also have a pop shut top. Okay, and you've got mounting holes, and I didn't mention those, the MIDI fuse bases have as well. Mounting holes, and these click together to form banks of fuses, so you can click all these together and mount them as one big row of fuse holders. I tend not to do that very much because I find it quite difficult to get the covers off. If you butt these up side by side, I can't get my fingers into to open them very well. So I tend to space these, you know, give like an inch between them to space them out. Mega fuses. So these start at 100 amp and they go all the way up to 500 amp fuses. So sizable fuses. I'd probably be quite happy. Would I be quite happy? No, I probably wouldn't. I probably wouldn't push these to 500 amps. I'm quite happy using 253, 350, 400 amps on these for inverters and things like that. But no, I don't really go any higher than that. There is a step up we can go. So these are your mega fuses, again available from AES, the link's below. And you can see they fit onto M8 terminals. So you pop the fuse in first. Oops, drop that. In fact, I'll show you that. In the base, the fuses actually click in. So you put the fuse in first, then you'd put the cable lugs onto these and screw down the locking nuts with there's a locking washer as well. And that's your mega fuse base. Okay, so great for inverters, larger currents above 100 amps. Is that it? No, there's actually another set of fuses that's even bigger, and they are called the ANL fuse. Okay, so you can see this one is actually a 400 amp ANL fuse. Now these are again bigger, beefier, and they fit onto an ANL fuse base. This is a typical type. There is normally a plastic cover that fits over there, but I couldn't find it. It's just one that's been rattling about in the van. So these fit similarly, but they've got slots in them rather than the holes. Okay, and the beauty of these is if you are changing a fuse, you can slacken the nuts off and take the fuse out without having to undo the cables and potentially have cables hanging around, positive cables hanging around. So you can replace these without taking those terminals off. You just slacken them off. So ANL fuses, again, these taking out to some bigger numbers. These ANL fuses are available up to a whopping 750 amps current carrying capacity. Now that number there is way over what we'd normally be using on a narrowboat for sure. You know, if you're using these things to inverters and that kind of numbers at 12 volt, increasing the voltage to 24 volts or 48 volts to bring that current down. So those would be really large numbers and the cables would be huge. So we wouldn't normally be going up to anything like that. I think when I'm looking at bigger inverters that take double fuses, double cable supplies, we're normally looking at a couple of 400 amp fuses, but certainly not very much more than that. Unless you got to some of the really big quattros and things like that might be a bit bigger. But yeah, they are available up to 750 amps, but we're not going to be generally using to that number. Now the advantage of these, like I said, is you can take them off without taking the cables off, but the bases obviously are designed to carry so much more current. They actually have a crossover to the mega fuses. So when you're up, I don't think I'd put 500 amp fuse in here. I'd put 4s in. But if you're going any bigger, then go to the ANL fuse type. You often see these on bell thrusters because they tend to be bigger fuses for that increased starting current. Yeah, you often see these on bell thrusters. So these are an ANL fuse, and I'll put a quick draw in here that gives you some of the dimensions on those fuses. But you can actually see, in fact, hopefully I could, those steps that I would take that would go from the MIDI fuse, the mega fuse, and then the A&L fuse at the end. There are crossovers between them, but as you get to the top range of this, consider jumping over to a mega fuse, and when you get into the upper current numbers on these, consider going over to an A&L fuse. The bases are so much stronger. Right, in fact, there's another A&L fuse there. That's only a 50 amp, that one, but you know, like I say, the bases are really strong and designed to carry their extra current. Those are the main types of fuses that I use in a day-to-day world, but there are others that you may come across. So in the same, we go all the way back down to the lower currents, where we're talking about these standard blade fuses, there is also a continental fuse. I don't have any with me because I don't use them, and I'll put the drawing up here. Now the continental fuses are more of a torpedo kind of shape, and there's two spring steel clips with holes drilled in them, and those fuses there sort of pop into them. They are pretty pants. I thought I'd got one then, but I haven't. They are pretty rubbish, because that steel gets tired over time. The contact patch on the two between the fuse and the holder is really quite small, but you see them in some of the old narrowboats, and there'll be a whole bank of them, and they'll be for lighting and pumps and all the same things that we use these for. So where I see those, I often recommend to customers that we change those and go to the more reliable blade type fuses. But they are continental type fuses. You do see them. They are about on some of the older boats. So what we may also see, and I do have quite a collection of these, are these glass type fuses, and they are called glass fuses. Again, the range is quite wide, and you can actually see possibly that they are 15 amp items in this particular case. So they tend to fit in like an inline fuse holder. I don't use them because I think that that one, the blade type fuse holders are sturdier, but you might see them when you buy, I don't know, a little charger or something like that. There might be an inline fuse holder. You open that up and there'll be these glass fuses inside. Now they are different to like the domestic ones that you might find in a plug. These are actually 30 millimeters long, as opposed to the others, which are much smaller. The two won't fit in either holder. So you might see some of these. There are also some 20 mil smaller ones that you might come across, but the same design. There's like a glass tube with a fuse inside and a cap at each end that makes the connection to the outside world. So you do see those about, glass type fuses. And I've got a few different sizes in those in little packets, but to be fair, I hardly ever see any of these. I've got another packet there. I hardly ever see any. By far the most common is these blade type fuses. Okay, now those glass type fuses, as I was just saying, you can actually get 50 amp glass fuses. I wouldn't be using them for that. If I've got 50 amps, I'm going to be putting a MIDI fuse in, so they are available all the way up to 50 amps. Now there are some other a bit more obscure fuse types, and one of those is a PAL fuse, P-A-L fuse. So I'll show you. I don't keep them. I don't think I've seen any PAL type fuses. They are automotive type fuses, and I'll put a picture here so you can see them. That's the type of fuse that's a PAL fuse, okay, P-A-L. So those PAL fuses are actually color coded, the same as the MIDI fuses. So where you see red and a 50 amp capacity, then the PAL fuse in red is also 50 amps. Okay, so you might see those around. I don't really come across those very often, but that is another automotive fuse that you might come across. Another sort of obscure is a battery terminal that has a fuse carrier and a fuse attached to it as well. You might see those. I've seen them now and again. the pictures there for those. I don't carry those in stock because if you've ever worked on narrowboats and when you see where the batteries are, to change those fuses could be a complete pain in the backside. So they are battery mount stud terminal fuses, and they're called a compact fuse that goes in them. Like I say, I wouldn't use those because they're just so awkward to get to. So they do exist, they are there. So with fuses, the rating on them, where it says 30 amps on that one, the orange one, on this little MIDI fuse, that means it can carry 30 amps constantly. So it doesn't blow at 30 amps, it carries 30 amps constantly, and will often blow at 2 times that. Okay, in a very short time, but it will often, generally to 2.5 times the current carrying capacities when it will blow. So, okay, so that's one thing. Going back on some of the videos and stuff, and some of the comments we've had have been great, and well, most of them are. Where the fuse, and I'm going to reiterate this because I've spoke about it before. The fuse is to protect the cable, not to protect the device that's over there at the other end of the boat. It's to protect the cable from where it's actually connected to, let's say the batteries, all the way up where that cable runs all the way up the boat. It's to protect that cable, not the pump or light at the end. That's why we always recommend putting the fuse as close to the power supply as possible. So if you imagine in this case, we could crimp a cable, a lug onto that, and put that straight onto that battery terminal. Pop the fuse in there. Now all of that cable down to the device is protected by this fuse, but this length of cable isn't. So that's the important bit. We make this as short as we possibly can. Not ridiculous. You wouldn't cut it there and pop it on the terminal, but you know, be sensible. You know, that bit of unprotected fuse, if it's not on metal and not wrapped round fuel pipes, don't do that. I've seen it. That bit of cable is unprotected, so we make this as short as practically possible is the wording we like to use, and then downstream of the fuse all of that cable is protected. That's what the fuse is for. I disconnected some solar last week, and they put the fuse at the solar controller side off to the batteries. Well, it's the batteries that are the greatest risk of supplying a fault to that cable. So the fuse shouldn't be at the controller end, it should be over at the batteries. That's really, really important, guys. Make sure your fusing is as close to the batteries as possible and it protects the cable. So on that note, if we ran a piece of cable that can carry 30 amps, argument's sake, and we put a 50 amp device at the other end and put a 50 amp fuse in here, then this cable now is not protected to enough of a level. So this could potentially carry 50 amps, more than it's designed to, and it could actually take 150 amps before it blows. So way above the current carrying capacity of that cable. That cable will get very warm. The fuse is to protect the cable. I cannot emphasize that enough, guys. Fuse is to protect the cable. Great. So when we're looking at everything connected to our batteries, everything from that battery should be fused. From those batteries should be fused. I'm talking about leisure batteries more than anything, because you don't often see them on starter batteries and things like that. Very rarely do you see fuses on there. But when we're talking about a battery bank of say 4 to 6 batteries, if you can imagine the amount of current that could pump into a load, it would be pretty scary and would catch fire pretty fast. So everything that comes off those batteries, please put a fuse on there. An isolator might be, in some circumstances, happy enough for boat safety. They're minimum specs. It's not good enough, guys. Pop a fuse on there. So every fuse that comes to a battery, but also everywhere where a cable changes diameter to. So you might put a cable up to, let's say, a distribution board that has, let's say, 10mm cable going to it, and you pop a fuse in there. If you then off that terminal then take a 1mm, 2mm, 2.5, 6mm, whatever, you've now that fuse isn't going to protect that cable that's connected. So every time we change from one cable size to another, then that should also be fused separately as well. Generally that's taken care of by some kind of distribution board. And yeah, by the way, I'm talking about the DC circuit at the moment. All these fuses are for DC circuits. I'm not talking about 240 volt. Okay, 230 volt. We've been to the 230 volt for quite a while now, but us old boys, we all call it 240 because we've always called it 240, and we know we're stuck in the rut, and we don't lose our habits very easily. So yeah, 230 volt. We're not talking about 230. We're talking about all the DC voltages, pumps, lights, all that sort of stuff in a narrowboat wide beam kind of thing. Right. So that's a brief view on fuses. I hope that's been some kind of interest and educational for some people. Like I say, aimed at boaters that probably don't know what those differences are and what those different fuses are best used for. So I hope that was useful. I'm going to cover some other things on breakers, DC breakers, and into AC breakers and things like that in another video later on. But right now, just the DC stuff, and there's the fusing. So hopefully you found that useful out there. Feel free to drop us a comment. Subscribers are going really well. I'm quite shocked, actually. I'm quite shocked at how quickly the channel has gone from where it was a few weeks ago to where it is now. So yeah, keep those comments coming in. Love reading those. And yeah, I'll see you next time, guys. Busy week coming up. Inverters to install, inverter chargers. I've got solar to install. I've got batteries to put in. Quite a lot of jobs coming up. So pop out, have a look at the other playlist that shows you the day-to-day electrical jobs I get up to. I can't film them all because they are so confined spaces sometimes, then it's quite difficult to do, but where I can I will, and share that with you. So right guys, thanks very much for watching. Give us that thumbs up and press subscribe so you don't miss anything, and I'll see you next time. Bye, see ya.